Okay, so here I'm going to talk about like building Web3 and why we chose Polkadot to do this. So first, let me introduce myself. I'm Luca. I'm working as a dev rel at Papermoon. So yeah, I'm from Argentina. I studied computer engineering and I have been working in the blockchain ecosystem for about like 4 years now. And yeah, I have also worked as a developer, like smart contracts, security stuff, things like that. Okay. So first, I want to start with a question. Why are you here? And by here, I mean, why are you at this hacker house? Why you are at Denver, okay? I think it's because of Web3. You are part of the Web3 ecosystem. And do you remember why you joined Web3? What was the value that made you start working here? So for me, at least, it all started with less trust, more truth. What does this mean? I mean, when it all started, everything like it was perfect. But then when you start like learning new stuff and going like deeper in the ecosystem, you realize that there are some challenges that we still need to like fix. So, for example, we have like layer twos in Ethereum that have like one sequencer or like a centralized sequencer, blockchains that have like centralized validators. Um, if you want to participate in a network, you need to like stake a huge amount of money, which not everyone can do this, and so on. We have like VCs that manage tokens, people that gamble in the blockchain. Now we have problems with blind signing that tend to involve hacking or things like that. So the key question is why we don't want to trust. Why less trust? And I think it's because the history and many things that have happened show us that we cannot trust like centralized authorities. For example, I'm from Argentina, and in 2001, uh, I haven't lived that, but my parents and people I care about, there was like a huge recession in Argentina, and the banks decided that they will like take people's money from the bank, and people couldn't withdraw the money from the banks. I think they only could like take $250 per week or something like that. And basically they took people's money from the bank. Then we have like, things like the 2008 crisis in the US with the housing market. We have like Cambridge Analytica that they use people's data for like political purposes. Um, we have like the FTX case where people thought their funds were safe with them and they were just lending them to Alameda and they gambled with that money, for example. So that's why we want to use Web3. We believe that Web3 is the tool, is the ecosystem provide us with this truth, the thing that we can actually trust. Okay. And these are all the characteristics, the properties that Web3 provides us. I don't know, it's decentralized, is interoperable, is open, everyone can participate. You cannot censor someone to participate in. So we have been talking about Web3, but now, what's the role that blockchain play? So if we want to keep things simple, blockchain is just a decentralized computer. It's a computer that is all over the world. We have computers running in many parts of the world, and all of those create this huge computer, all right? And if we want to keep it simpler, we can say just that blockchain uses cryptography, so we can actually verify that a certain of events haven't been tampered with. Like we can make sure that event one happened before event two, and we know the rules that led to that transition. Okay, but how is it done? Like in simple terms, we can say that state machines. State machines are a simple construct that has two rules. You have a set of valid states. I mean, each state has to comply with certain rules, and then you have other rules for transitioning between states. So if you're in state one and you want to modify something, you have to follow those rules. You cannot do it other way. And you have probably seen this diagram all over the place, like in every blockchain. But the key thing to understand is that in what we call blocks, it's not the data is not stored there. The only thing that we store there are the state transitions, the things that were made to go from state one to state two. Now, we know what's blockchain, but now what we use it for? So basically, blockchain allows us to provide like secure, scalable, and infrastructure for applications. Let's imagine blockchain is like a AWS, Azure for what's for Web2 now. It provides you to the logics that you can do for your apps, okay? And the product that blockchain sells, is Blockspace, okay? Blockspace is, in simple terms, is the possibility to commit operations, to do something. And this can be execute arbitrary code, store data, data availability, all of those things, okay? But Blockspace is not the same for every blockchain. It has properties, okay? So, which are these properties? For example, we have quality. It's like how secure is the block space. It depends on the amount of money that validators and the network has. So let's say if someone in the Bitcoin blockchain, right, managed to create the longer chain, they could like switch the chain and have a different reality, okay? So another quality is availability, okay? How much block space is available? I mean, is it limited? There's a huge amount of block space. And also, I think the most important one is flexibility. How many applications compete for the block space? It's not the same a block space that's for like doing general purpose tasks or another one that's specialized for like a certain use case. So here we can talk about like generalization versus specialization, okay? And we're continuing with like this flexibility property. When we talk about like general purpose blockchains, we can think about something like Ethereum, where all the applications that are deployed to that chain are competing against each other. We have like DeFi protocols, NFTs, supply chain. All of those things are between the same network and are competing for the same block space. For example, let's say I want to send money to a friend in another country, right? I will be competing for the same block space as someone that's trying to mint a new NFT. And I'm going to pay more money in fees just because we're competing for the same. The other different approach is having specific purpose blockchains. We can have a blockchain for DeFi, and we can even like split it up, like one blockchain for decentralized exchanges, another one for lending platforms. We can have blockchains specific for AI, data storage, and this seems incredible, but also has some challenges. I mean, you need those chains to communicate with each other so people can actually use them and create stuff over it. So Polkadot is built having this in mind. I mean, Polkadot is a specialized network that allows you to create blockchains for specific purposes, okay? So we can say that Bitcoin is a simple chain in terms that it only allows you to transfer money, right? Transfer Bitcoin. I know there have been a few updates like Taproot that allow you to execute code, but when it started, it was just for transferring money, okay? Then Ethereum came and allows us to create basically arbitrary computation, and Polkadot is like the cloud. We can say that Polkadot is like what AWS is for the Web2, all right? So when we talk about Polkadot, it's important to understand how it is built, okay? Like the formal definition is that Polkadot is an heterogeneous multi-chain protocol that secures and connects blockchains with pool security and interoperability. I know this is really complex, and the idea was to read it, okay? But if we want to make things simple, Polkadot is just a set of blockchains that can work together and communicate with each other. So the architecture of Polkadot, like the basic thing, is that we have two components, okay? We have the relay chain, which is like the hub of Polkadot. It's the chain that provides the security of the network. And then we have the parachains that are all the specific purpose blockchains built by the people, basically. In Polkadot, we have some parachains that are created by Polkadot. These are called like system chains. So we have like a chain for managing assets, another chain for managing like people and stuff like that, okay? So when Polkadot was built, it had a few values in mind. that society and technology evolve, I mean, the people are evolving all the time and their needs can change. So it doesn't make sense to create a technology that cannot evolve, all right? Humans are fallible. I mean, we make mistakes, so we need to be able to correct them and keep them ever growing. And the best decision of today is the mistake of tomorrow. So, with those values in mind, before creating Polkadot and before creating all of this, they created Substrate, which now is known as the Polkadot SDK. And this is a Rust framework for building blockchains. I mean, you may know that creating a blockchain from scratch is really hard. Like the technicalities needed are way more complex than writing just a smart contract. So this framework tries to solve this by providing you with the building blocks to do this. And Substrate have like a few properties we can mention here. It allows you to develop blockchains in a modular way. Also, it provides like the libraries for doing like things like networking or several logics for your chain, like managing funds, transfers, creating like native multisigs, all of those things. So the architecture of a Substrate-based blockchain has two main components, the runtime and the client, okay? Now we're going to go a little bit more in depth, but have this in mind. So when you're writing your own blockchain, like your specific purpose blockchain, most of the time you will just be coding the runtime. The client is everything else. It's like the networking, the database, the mempool, the consensus of your blockchain. But the business logic is going to be implemented in the runtime, okay? And that's where people tend to dedicate their resources, okay? So the runtime is the application logic. It is compiled to WebAssembly. And this is a really important thing about Polkadot. The logic of your blockchain is stored in the same state of the blockchain. And this allows for certain properties that we're going to mention later, okay? So why we need the runtime stored in the chain? You know, when you want to upgrade a blockchain like Ethereum or Bitcoin, the only way to add new features or to fix something is through a hard fork, okay? All the validators need to take a decision, they need to shut down the server, start again with the new software, and then the consensus reaches and the blockchain is started. But if there's people that do not do this, they're going to keep running a parallel chain, right? So here there's a hard fork produced, and it's complex to manage this. In the case of Polkadot, because the runtime is stored as part of the chain, you can just keep going and you don't have to like stop the server or anything. And let's say in the example, we have in block 104, the runtime number 1, it is upgraded, and then in the block 105, all the validators are running the new state, the new runtime. And also, the Substrate framework allows us to create fully on-chain governance, which is something different that not many protocols have. So the key thing about having a fully on-chain governance is that people is in control of the chain. The Polkadot token holders basically have decisions of everything over the chain. Every proposal is initiated by someone of the public, like anyone can create a proposal. Every dot holder can vote on it, and the protocol will evolve based on those decisions, okay? Now, for developers, in Polkadot, we have like multiple development pathways that we can take. You can go to parachain development, you can develop smart contracts, or you can go to developing applications in top of smart contracts or parachains, okay? And here you have to have in mind what's the actual need of your product. You don't have to say, oh, I want to build my app chain, my parachain. I think this is like a really important decision to understand what you need for your product and when you actually need a smart contract or when you need a parachain. So if you go to the path of creating your own parachain, on top of Substrate, there's another framework called Frame, which takes the opinion that everything has to be built like in modules, all right? And Frame, the interesting thing about it is that there's already like a huge collection of palettes that are already built. So if you want to create your own blockchain, you probably don't need to write almost any code like for your logic. You can just like go through this collection, choose the features you want, write some configuration files, and then you can create a runtime and run it, okay? So these modules that you have for writing your runtime are called palettes, right? And if there's some feature that's not actually implemented and it's not in the collection of palettes, you can write it by yourself, all right? So I'm going to go like really over it, but we can talk about it later in the workshops that we're going to have after lunch. But basically, the architecture of a palette is something similar to the smart contract interface. So you have like functions that you can call from the outside world, which are called extrinsics. Then you have the variables that you want to store in there, which are the storage items. Then you have events that basically allow external applications to know when something was modified and react to it. You have like errors, hooks, and more things that you can do. Also, you can develop smart contracts and deploy them to Polkadot. All right. There are some palettes that emulate the exact same behavior as the EVM. So for you, it's going to be the exact same thing. You're going to connect with the Ethereum compatible wallet to these chains. You can deploy your contracts. You can use like Remix, Hardhat, all the tools that you use for Solidity, for EVM chains. You can use it for those. And there's also another smart contract execution environment called palette contracts that you can deploy WebAssembly smart contracts. So for the cases of like the EVM compatible one, any chain, any substrate-based chain that implements the palette EVM and the palette Ethereum can be used to deploy your smart contracts transparently. Like it's exactly the same process, okay? And we have some examples like Akala, Moonbeam, and some others. Then for the WebAssembly smart contracts, basically you can do that. You can deploy them to any chain that has the palette contracts implemented. We have some parachains like Aleph0, Astar that have this. So you can research about them if you want to go with this path, all right? So here the decision is on you on what do you want to develop. I mean, if you really need to do a custom-made blockchain with like, I don't know, like shorter time between blocks, or you need like custom fee management, stuff like that, you can go and develop your own parachain, okay? But if you just need to execute certain logic in a decentralized way, in a deterministic way, you can just go to smart contracts and use that, okay? So, I mean, beyond the technical details that we were just mentioning, I think we still have something to talk about Web3. There's a huge difference between what we can do in Web2 and Web3. And that difference is resilience, okay? In Web3, we're resilient against like censorships, single point of failures, hacks, all of those things. For example, have you seen what happened to Bybit on Friday? Basically, they were social engineered and they did some bad practice on their security, and they lost $1.5 billion of the users, basically. And for me, those are not real Web3. I mean, people deposit their money on a centralized exchange and they lost the money, basically. That's it. So in order to solve this, we don't need to trust people. We need to trust code, okay? And that's why I think Web3 needs to succeed. It's not something that we may do. It has to be real. And Polkadot is the way that we can do that, okay? But why? Because Polkadot achieves resilience not just in the technical side, but in every part of the network. I mean, we talk about the technology, but also the ecosystem, the community, everyone in the community, in the Polkadot community, wants to make this like dream come true. So the future of Web3 is in your hands, and you have to take a path to shape it. So you can choose develop your parachain, develop your smart contracts, your new applications. So yeah, that's all. Thank you. So if you have any questions, here are the slides if you want them.
Yeah, can you talk more about the relationship between the relay chain and the parachains? I was kind of confused on the responsibilities, specifically of the relay chain.
Yeah. Yeah. Hello. Yeah. So, I mean, the key thing that you need to understand is that the only purpose of the relay chain is to collect all the data generated by the parachains. Like each parachain has their own business logic, right? So they have their own consensus, their own logic, whatever. But they are connected to Polkadot because Polkadot is the one in charge of providing security and finality, right? So I don't have the diagram here, but I can share it with you later. So basically, when a parachain provides all the state changes that the parachain generated, they provide something that's called a proof of validity. So the actual validators of the relay chain take all of those state changes, take the proof of validity, and they actually make sure that the changes made in the parachains are valid, respect the state machine, okay? So basically, the key thing that you need to understand is that parachains have like specific purpose applications. You can do whatever you want, AI, DeFi, doesn't you? But the relay chain is only its only responsibility is to provide the security and the network.
Okay, so the parachains can derive their own consensus mechanism, but in terms of security, the relay chain is what provides that. Gotcha.
Exactly. I mean, if you want, you can create a parachain that have just one owner and that takes all the decisions, and you can also do that.
Cool. Thank you.
Hi. Hi. Yeah. You mentioned like I think Akala and Moonbeam, they have the EVM palettes or the like Ethereum palette. So if I want to deploy my smart contract, how would I one, are there any other parachains other than these two examples? And two, how do I decide between them which one I should just deploy on?
Yeah, there are other options regarding like EVM compatible ones. I don't have the list here, but I can share with you later. And deciding like which chain, I mean, that's probably up to you. You can check like which applications are deployed in each of them. Yeah, I don't want to mention one or the other. I mean, each of them have like different features.
Okay.
So yeah.
Okay. Okay.
Well, I had one more question. For that protocol, for that protocol upgradability slide, and maybe this is a conversation we could have async, but I was just curious on how the upgradability for substrate-based blockchains differ from the legacy one. Like, I understand there's a difference, but I'm a bit confused on the nuance of it.
Okay. Yeah. So in the substrate-based blockchains, I mentioned that you have palettes, right? So each palette have like certain functionality. In every substrate-based blockchain, you have a palette called system that has one function that's called like set code, upgrade code, something like that, right? So there you have to have a like certain access control. As I mentioned, you can do it like have one owner and he can just change the chain logic, or you can have like a governance. Like for example, in actually Polkadot, this extrinsic can be executed only when the governance decides to do so. So basically, you submit that function with the new logic, and in the following block, it's changed basically.
And that's only if it's approved by that chain's consensus.
No. I mean, it depends on the logic. So if there's a single owner, you execute that extrinsic, and that's it. Like in the next block, you're executing a different logic.
Interesting. Cool. Thank you.
I have another question.
Yeah.
And can you talk more also on the West End testnet and
Yep.
how that differs from deploying on one of the parachains?
Yeah, I haven't mentioned that, I think. But regarding smart contracts, like in production, you only have like those two that I mentioned, which are like the fully compatible ones with like EVM. which are like Moonbeam Master, and Ink, which is like the palette contracts, which are the WebAssembly ones, right? But there's like this new thing that is being developed actually on Polkadot, which is already live on testnet, which is now is in the Western testnet. So the architecture is a little bit different. So it's not actually an EVM. It is called Polka VM, which is based on like the RISC-V architecture. So for developers, you are going to write the smart contracts using almost the same tools. Like you can use Remix, you can use Hardhat, you can use all the same thing. But the difference is that instead of compiling with regular Solidity compilers, you're going to use a different one, which is called like Revive, which is going to take your Solidity code and instead of like outputting the EVM bytecode, it's going to output a different binary format, which is compatible with Polkadot. But then the features are exactly the same.
Okay. Okay.
I just had a quick question. I just wanted to know what the difference between the West End testnet and the Kusama testnet are.
They really want you to use this.
What are the differences between the West End testnet and the Kusama testnet?
So Western is like an actual testnet. You don't have value in there. So basically the tokens are worthless. Kusama is like a middle ground between Western and Polkadot. Polkadot is like the fully production network that you have all the most stable features. Kusama has real value, like the tokens have a price, right? But the features that are pushed to Kusama are not always stable, or they are like for testing purposes with real value. Because we have seen like in many blockchains, you have just the testnet and the production network. So when you deploy things to the testnet, I mean, people are going to try to break them or those things, but because it has not like real value, maybe some bad actors are not going to actually like take the time and the effort to do so. So that's why Kusama exists. It's like this middle ground.
So would you say that West End and Kusama kind of function as like an alpha and beta testnet?
Yeah, we can say that definitely. Yeah. Do you have any more questions or?
Yeah, I mean, it's more than beta. So there are also functioning like parachains there, who have their home on Kusama. And also, I don't know if you are aware of the recent proposal on Kusama governance. So they have a broader vision for Kusama now. So they want to make it a ZK experiment net with $10 million, sorry, 10 million dot coming in to bootstrap all those activities. So definitely it's a step higher than a beta testnet. So it's more of a, yeah, exactly. It's where like people can do fast-paced prototyping and experimentation.
Thanks, Vlad. Okay, thank you very much.